In this video, we're going to build what's called a Maclaurin series. Now, a Maclaurin series is a Taylor series where the point that we're starting at, the point we're plugging in, is 0. Okay? So, if you recall, the Taylor series always had, the derivative evaluated at a and then x minus a to the nth over n factorial. Well, this has the derivative evaluated at 0 because that's where we're centering it. X minus 0 to the nth would just be x to the nth. So it's a Taylor series. Okay, a Maclaurin series is simply a Taylor series where that spot that we're centering around is 0. Okay? So e to the x, where a is 0. So I would start with some derivatives, all right? Let's start with the function. It's e to the x prime I usually go maybe 3 or 4 down to help me find the pattern for the general term. I think it'll be easier in this case because, of course, e is its own derivative, but it usually gives me a nice beginning. Okay, and then we evaluate this because we want all of the derivatives. We want them evaluated at a, which in our case is 0. So we're going to evaluate them all at x equals 0. So let's fill that in. E to the 0 is 1. So every single one of those is 1. Okay. So the first term would be 1 over 0 factorial. Okay, because it's the 0 derivative, which is just the function, and 0 factorial. And then it'd be x to the 0. All right, next, the first derivative is 1 over 1 factorial, x to the first. Second derivative over 2 factorial, x to the second. Remember, those all agree. The second derivative goes with x to the second power over the second 2 factorial. They always agree. Third derivative, 3 factorial, x to the third. Fourth derivative, 4 factorial, x to the fourth. Now, I'm going to write the general term underneath it, but I'm going to simplify it and then write the general term. Sometimes it's nice to not simplify it. It helps your general term a little bit. So let's write the simplified version underneath here. But I'm gonna maybe just kind of put a little circle around this. This is the non-simplified term, and I guess I should also put a ... there because I didn't go further. But I think we see the pattern. All right, simplified. Well, 0 factorial is 1, so 1 times x to the 0 is just 1. 1 over 1 factorial times x to the first is just 1x. Remember, those first 2 terms, that's the tangent line. Okay, that is the tangent line. Next, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, and so on. So let's get the general term. Well, it's not alternating, so we don't need to worry about that. We have x just picking up a power every time. So it'd be x to the nth power. And we're dividing, we have a 1 over n factorial in the front. If you wrote this is the general term. If you want to write it as a series, you'd probably just do this, start it at 0, go to infinity like that. Because e is its own derivative, right? X to the second, 2 factorial. X to the third, 3 factorial. X to the fourth, 5 factorial. Or x to the fifth, 5 factorial. So this would be the general term, or I guess I put the sigma in there, so it's actually the series now.